Welcome to today's Postgres conference webinar, The Data Bottleneck, the Data Engineer and How We're Trying to Fix This. We're joined by Seattle data guy, Ben Rogojan, who will discuss how the data engineer ends up being the bottleneck, as well as the various solutions that many companies are trying to use to fix this problem. My name is Lindsay Hooper. I'm one of the Postgres conference organizers, and I'll be your moderator for this webinar. A little bit about your speaker. Ben has been a data engineer at organizations ranging from Facebook to Healthenic. He has extensive experience designing ETL pipelines, databases, websites, and other software products for startups and already established corporations. Today, he's probably known best as the Seattle data guy, helping small to mid-sized companies manage their data. So with that, I'm going to hand it off to Ben. Take it away.
Thank you. Thanks so much. Thank you also for everyone who's joining for this talk. Again, my name is Ben Rogojan. Kind of been working in data for a while. Just to give you, just to kind of give you a quick background on me. I originally started in healthcare analytics. First in a hospital, then kind of going into a healthcare analytics startup called Authentic. Since then, I also have consulted for several companies under the company that I've called Seattle Data Guy. So that's included companies in the finance, insurance, transportation, SaaS, and some other industries as well. Through that whole process, I think I've had a good opportunity to see various data solutions in play. I've come into companies where they had nothing, maybe they've had a product for the last 20 years and they've had data on it, but they need to now start actually analyzing it and working with it and trying to actually, bring some light and insights into kind of their whole process and how they could actually monetize or gain new insights about the products and services that they're offering to either help optimize their services or create totally new products altogether. Again, since I've kind of had that opportunity to come in and see various situations, I think I've seen repeated problems over and over again, in various companies, especially once you start going at larger companies, you start kind of seeing the same issues in the data space, regardless of where they fit in terms of tech maturity. So I think that's kind of given me that kind of interesting perspective as far as data engineers and as well as the end-to-end kind of data solution and where problems occur in that data pipeline. Along with that, I've kind of become an accidental writer at this point, just due to the fact that originally I started writing on things like Medium and my own personal blog for the reason of gaining clients and sharing my expertise with various people. So at this point, I think I've put out over 200 articles and also had the opportunity to write for various companies, including companies like Panoply and Rockset. So that's kind of another just a little bit about me. If you need to find me, you can pretty much look up Seattle Data Guy across your various social profiles, whether that be LinkedIn, YouTube, Twitter, Facebook. You will find me there. So that's just a little bit about me and kind of what I've done so far as far as in the data space. In particular, I think I've focused more on data engineering, but also I've done a lot in terms of like some data science and dashboarding work. Okay, so just the general concepts of what I'd like to cover today. The general agenda, we're kind of going to review, what is a data engineer, just so, regardless of where you are in your experience or where you are in your journey, you kind of just get where I'm coming from and what I'm kind of thinking as far as data engineer and what they do. As well as discussing kind of why they've kind of ended up as this bottleneck, and then kind of talking about some possible solutions that companies are trying and testing and working through to try to speed things up, and talking about things that are working very well, and maybe talking about some things that still, in my mind, don't necessarily fit or maybe aren't working as well. Okay, so generally, when I explain what a data engineer does or what is a data engineer, I generally explain it as someone who moves data from point A to point B. Obviously, that's a little more complex than just that, right? Like we could set up an automated system to pretty quickly just take data and copy a database over very easily. But that's kind of the baseline of what a data engineer does. I generally also like to explain that they are kind of a middleman between applications and third-party softwares and also integrations with external vendors. And the data analysts and data scientists. So they really get to play this role where they're often the ones who are holding back the data from data analysts and data scientists. So, in order for data analysts and data scientists to actually access information, generally a data engineer needs to kind of step in and pull that data, remodel it, and make it easier to access. And this is usually important because, companies' data generally, or not companies, but application data can be kind of messy, as well as not necessarily structured in such a way that might be familiar to especially data analysts and data scientists who maybe are just familiar with more what we call denormalized data sets that are very kind of large and very easy to kind of manipulate. So data engineers usually spend time remodeling data in such a way that's very easy for someone who maybe doesn't necessarily understand how all the business logic, can kind of just come in and trust that that data is at least somewhat accurate and somewhat processed and cleaned. And a lot of their time creating infrastructure to support automated processes. Depending on the company you work at, there are a lot of different solutions here. Some companies are building their own kind of ETL management systems. Others are using out-of-the-box tools or like out-of-the-box libraries. Like if you're familiar with like Airflow or Luigi, these are some very familiar tools for data engineers. Where you're not having to spend a lot of time actually creating all that infrastructure and automated processing. And so that's kind of what I think of as far as data engineer. They really are that kind of middleman that helps make data or some sort of data layer that's very friendly for end users, whether that, again, be an analyst, a data scientist, and even nowadays I see a lot of like project managers, product managers get very into their data and try to access it and slice and dice it through various tooling like Power BI or a Power Query, Tableau, et cetera, just because it's getting easier to access, but now they just need someone to actually they just need it somehow transported into a layer that is easy to access. So just kind of to understand what data engineers do, maybe some of you are data engineers, so this is just your everyday. Basically, again, you're pulling from various sources. Again, it could just be a third-party tool like Zendesk or Workday. It could be a CRUD or sorry, an OLTP like MySQL that's basing your company's data or application in, and then they're doing some sort of ETL, which is kind of that middle section, which generally is a bunch of organized tasks that basically process that data and then put it into some sort of data warehouse. I've used Snowflake just because that seems to be what everyone's currently focused on, but really I've seen data warehousing, actually, just since we're on Postgres, I honestly use Postgres a lot for a lot of the data warehouses I build, just because I found it's sufficient for companies with small and medium data sets when you're not having, hundreds of thousands of users having to process it. So that's also, a possible end result for a data warehouse. And so that's generally kind of the goal. We generally spend a lot of time building these ETLs and connectors as well. So the one thing I didn't include this is some sort of connector to all of these various data sources, right? Like you've got to connect to some sort of API like Zendesk that Zendesk might have or that Workday might have. And that takes up a lot of our time as far as spending a lot of time coding and actually developing these pipelines, as well as developing custom connectors for all these various solutions. So another kind of point I like to point out, or another concept I like to point out, is the fact that the data engineer field is growing pretty rapidly. There's actually two different reports that I found recently that pretty much stated that between somewhere in 2019, 2020, we're seeing somewhere in the range of 40 or 50% growth in the roles for data engineering. In the terms of interview query, they did some research as far as looking at what kinds of interviews were being done, and they found that data engineering interviews were growing at a rate of about 40%, whereas data science interviews were kind of dropping. Similarly, in DICE also provided some similar information as far as data engineering roles also growing by about 50%. Are really kind of hounding for data engineers because they need someone to access and pull and manage all this data. In fact, I recently saw an article where they were talking about kind of the data engineer being your first kind of hire as far as when you're trying to set up a data team, because they're the people who are going to set up your whole process as far as that core layer of data, processing or accessing data, but they can focus a little more on the actual analytics. So one of the reasons I think we're seeing tons of this growth is data is continuing to grow. I've just put in a few data system possibilities that you could be pulling from in this picture, but really there's probably hundreds, and if not possibly thousands of data sources that we're all trying to pull from. I like to think that data is kind of very derivative of a day-to-day of a company, or it could also be just other resources in general. And so we're trying to gain some insight into actually being able to see what's happening in a company. Back in the more early 2000s, early 1990s, we had a lot of ERP our data came from, and that was very limited in terms of like the transactional information that we gained. And then we started to gain a lot more as things like IoT and mobile devices and web and tracking web commerce became even more popular, just because it gave a whole new kind of layer of information that didn't really exist before. And so with that, and with all those new kind of data sources comes the need for even more data processing, even more what we call ETLs or some sort of data pipeline, just to try to get all this information, right? Companies are all trying to vie for all this information, trying to get new insights, trying to about their day-to-day, and trying to optimize their whole processes. So just to kind of, I guess, reiterate before switching from this slide, yeah, basically, what companies are kind of dealing with is the need for all this data and the need for finding a way to actually pull it out quickly and effectively. And that's, I think, in many ways driven the need for more data engineers, but also in many ways, I think many companies haven't really set up for this whole, basically for the ability to set up and manage all these data processes that are coming down their pipelines. So that's kind of a good outline for what is the problem, right? Like when we start looking at it, as far as like, again, data becoming more expansive, as far as we're getting more information from more places, which in many ways is seen as a benefit, as a lot of people are focused on concepts like big data. But I like to also say big data is just as much of a big problem as it is a possible solution, just because at the end of the day, trying to wrangle and manage and put some form of data governance over all of these different data sources becomes very difficult very quickly, and I think it's just expanding more as time goes on. Basically, kind of what I've heard and what I've learned from talking both from companies that I've worked with, as well as external friends and in the data science and data analyst space, is oftentimes they're all wanting to access the data, but for some reason, well, not for some reason, but they often are stuck behind some sort of data engineer who is kind of juggling, a myriad of tasks, and then somehow it has to manage all of the various data requests that are coming in, create the automated connectors for the new application that the company has just pulled in for some new initiative, and is now having to basically create and spend a lot of time just getting all that data from point A to point B. And they end up kind of having to juggle all these various requests and initiatives, which in turn ends up slowing them down and creating this kind of bottleneck where data analysts have needs, data scientists have needs, PMs are often also have needs as far as trying to figure out information. They might have ad hoc requests, and just all these different layers of kind of tasks and goals that are kind of being slowed down by the data engineer. All right, so that's kind of as far as like me stating, the data engineer being the bottleneck, and kind of how they've kind of landed into the situation where, again, lots of companies have all this data and are just getting more and more applications that produce and provide data through various APIs, which just in turn provides more and more work for the data engineer who's trying to pull all that into some sort of data warehouse while also creating some sort of core data layer. So what's the kind of work that's slowing data engineers down? I like to say it's a lot of operational work. So in particular, every time you add in a new pipeline, it seems like you will almost immediately get new requests for new fields. So, you add in some new Asana pipeline, and then suddenly people need new fields from it that you didn't pull in. And so that often slows you down as you're having to kind of go back and work through those situations. Migrations, I think, is another key area where you spend a lot of time, just because
at the end of the day, companies are constantly looking for either improved performance, cheaper costs, or something similar. So they're often migrating from one data warehouse to another, or one ETL provider to another. And this can also be very costly. Also, as companies, I think, are switching over to trying to do more streaming, that takes up a lot of data engineering's time of producing new pipelines, and instead focuses them on some of the old stuff. And again, as they're kind of doing that old work, they're really losing out on all these new data applications that are coming in, and new kind of data sources that companies want to pull in. Again, kind of forcing companies to look for more data engineers in kind of a result. Also, changing APIs. If you've ever worked with most APIs, they're always changing, to some degree. Sometimes it's minor, you don't have to change anything with what you're pulling, but sometimes, data fields might get pulled away or might get changed. The naming convention might change slightly. And depending on the company that you're working with for that application, this could happen anywhere from 6 months to a year. And you can spend a lot of time just having to deal with the small changes that APIs make as they're kind of improving their own systems. Another thing is changing goals. So, companies are constantly changing goals, and I've seen this both in large companies as well as consulting. If as companies change goals, it makes it very difficult for data engineers to keep up and manage their resources effectively. If companies change to wanting to build some sort of ML model where the data doesn't exist yet, and now the data engineers have to kind of shift their goals and their projects, it takes a lot of time to kind of make that shift. And so a lot of times you'll see that kind of, I think, data engineers kind of get stuck in all the business goal changes and alignments, and in turn kind of slows them down as well. And finally, some poor infrastructure decisions. So depending on how a company has set up their data pipelines to begin with, can really permeate through history in terms of, there are a lot of companies that are trying to develop their own ETL systems where maybe they could have used something like Airflow or something similar that already has a lot of the various components like metadatabases and dependency management. And that those kind of infrastructure choices can lead to a lot of time spent down the line. Again, either one, migrating, or two, having to deal with kind of an archaic system or something that's maybe put together by some team of engineers that maybe doesn't even work at the company anymore. And that can kind of slow down the process because maybe, it's just more difficult to work with that system. Maybe that system isn't automated. Maybe that system doesn't have some key benefits that a more mature ETL management system might offer. And so I often kind of refer to those kind of things as like spaghetti pipelines, where you often have all of these different components put together. Like, someone's got some bash scripts in there, someone's got some PowerShell, someone's got some Python. It's all kind of managed through some sort of cron job. Maybe you got some CSV config files or JSON config files in there, and it can get really messy really fast. And as companies grow, in particular, this becomes arguably very unsustainable. It's one thing to do this when maybe you have 10 pipelines and you're kicking them off manually anyways because you're only using this report once a month. And it's another thing to try to manage large corporations through this kind of whole process, or maybe just large corporations teams, and each team kind of just has their own individual tool that they like using, or individual sets of tools. One team uses MicroStrategy, one team uses this more spaghetti pipeline method, another team uses SSAS, another team uses Azure Data Factory, and all these different kind of layers can just make it very difficult to really get a handle on all of your data as things are changing and as companies need to kind of scale and expand quickly with their data. And so this is, again, kind of the major problems I've seen data engineers deal with, and in turn, those problems become the problems of data scientists and data analysts who are stuck waiting behind data engineers who are just trying to juggle all these various issues. So what's the solution? This is kind of the problem, right? Like one thing that companies are trying to do is obviously hire more data engineers. But again, if you don't have things like the right infrastructure or the right alignment as far as goals go, it really doesn't solve your problems. You're just trying to put more bodies to an expanding problem that will probably expand faster than you can hire people. And I like to say it's a multi-billion-dollar solution because we're seeing so many companies either that have existed for a long time, or are that have kind of come into existence in the last couple of years get billion-dollar valuations or have had billion-dollar valuations for a long time, trying to solve this problem essentially through various ways. If you've heard of like Fivetran or Rivery.io, both of these companies have basically tried to approach ETLs by switching more to an ELT model, as well as providing things like automated connectors and really a lot of that change data capture and all these different things that data engineers try to do into one system, rather than having your data engineer spend a lot of time kind of do that like 80% work that many of them do, which is again creating custom connectors, creating some baseline pipelines just to get data extracted from your applications and things like that. You also have things like Denodo, which are doing more data virtualization. Matillion, again, is more like kind of an ETL, ELT tool. Also got a ton of funding this year. And MuleSoft is somewhat similar. I think MuleSoft also plays more of like an integration role where they're trying to integrate data across applications. But I think in some ways it also has some similar connotations in terms of trying to process and manage data in one way. And again, I think these are all kind of having all of these have different solutions or different methods for trying to solve the same problem. Fivetran and Rivery are both more automated connector kind of tools. Denodo is more of a data virtualization tool. Matillion's kind of this ETL tool, and they're all trying to provide some way that reduces the amount of time your data engineers spend processing, managing, and creating data models and data warehouses, data lakes, and so on. And so what a lot of these tools offer is various kind of components. I think one of the ones that I've seen that work well and companies are taking advantage of are automated connectors. So, I think I've had to write various connectors like an Asana connector or Salesforce connector once or twice, at least in my life. And, I'll probably have to write it a few more times depending on the company I work for, just because of the fact that, you're dealing with all these tools at all these companies, and it's very repetitive, right? So automated connectors are trying to basically remove that rather than you having to write all this custom code. You can now spend more time, hopefully just connecting automatically to these APIs, whether again, that be Workday, Salesforce, Asana, Zendesk, whatever it might be. And just automatically basically click a button somewhere and it automatically pulls into your data warehouse. There are various ways this can happen. One company I didn't include on here is Panoply, which also has some similar benefits as well. All of these, again, trying to basically reduce the amount of time your data engineers spend coding. Oftentimes, these can interact with somewhere in the range of hundreds of data connectors. And again, this really can reduce the amount of time that your data engineers spend doing very redundant work, which is often just setting up another request API data connection just to pull data in. And again, this tends to be very code heavy and arguably very wasteful of their time. Also, one of the benefits of this is oftentimes these tools might try to keep up with the API changes. So as APIs change, they might try to kind of keep up with it all in terms of actually trying to manage the whole process and you not having to sit there and update your various systems for every API change that happens along the way. So that's another kind of benefit of automated connectors. And although I've included like Fivetran and Airbyte on this picture, even things like Google and Azure have some automated connectors that you can either come out of the box or you can kind of implement into your system. So there's really a lot of options as far as automated connectors go. You're not limited to startups or companies that are just coming about. Another area that I think we're seeing a lot of people trying to turn into or focus more on is ELTs versus ETLs. So for those who don't know, I kind of lightly covered ETLs earlier. It's that extract, transform, load, which is just the process that we, for the longest time, have used as far as like managing business logic and processing data, cleaning it, and actually trying to get it from point A to point B very quickly. One of the ways, the problem here is this is often a very kind of slow process because implementing that business logic often requires a lot of time. You're often going to spend a lot of time QAing code, trying to manage your whole system, ensuring that logic is accurate with business users and things like that. So it's very time consuming. Whereas ELT, you just move where that transform happens. So instead of happening basically with the data engineers, oftentimes you try to move it more towards the analysts or towards someone else other than the data engineers, so that the data engineers can kind of more focus on creating core data layers versus providing the constant reporting or ad hoc requests that a data analyst might ask for. And so the focus here is really on just getting the data into your data warehouse or data lake. Generally, it's more likely a data lake. Data warehouses, I think, are a little cleaner and focused on trying to really create that curated data set. So usually it's in something more close to a data lake where you're just trying to get that data into your system. That way, your data analyst, data scientists can do a lot more of that ad hoc work right away. It pushes that business logic downstream, and it really speeds up the whole process. Again, you're not spending all this time creating the logic right away. The one thing I usually ask here is, who's actually tracking the data governance? Like where are we ensuring that the data getting pulled is actually accurate information? Of course, this depends on where you're pulling the data from, but I think that's always a good question to ask as you're doing ELTs. You're still needing to do a transform somewhere. You're not fully getting rid of that need as far as managing and ensuring data quality. So that's usually a point I will just reference, as you're setting up this whole process. I think even when I've worked with companies that are doing more ELT fashions, they generally still will have 3,000 line queries sometimes just to try to model or manage the data. So I don't think we necessarily get rid of the transforms. We're just kind of moving it down the line. But I think there are a lot of opportunities here because we're seeing things like DBT and other tooling to help manage those kind of transforms. And so I think there are a lot of opportunities, and I think I generally do like the ELT fashion, but I do think there are just some extra steps that are worth thinking about as you're using automated connectors that then connect into some sort of ELT in order to actually manage that data, that final kind of data model that you're eventually going to build and use for reporting. One more comment. I think another benefit of ELTs is the fact that you can now use them very easily for data scientists who maybe just want to do quick research. They don't even know if there's any value in a data set. So it's often worth getting that data early for them just to spend some time cleaning it and looking at it and actually seeing if it's even worth pulling into a core data layer, right? Because there's so much data out there. I think making sure you have a process around all of it can be very difficult, but if you can tell early on that a data set is worth it or not to pull in and actually process and clean and actually create a core data layer or data model, I think that's worth spending some time doing ahead of time rather than trying to do a ton of work and then figuring out that there isn't a lot of value that the company might want from this specific data set. Data virtualization is kind of another interesting method. Instead of actually pulling that data and making a duplicate copy, you're often leaving the data in its source, wherever it lives. It could be a data warehouse, it could be a MySQL database or a Hadoop cluster, whatever it might be. But it really allows you to essentially access your data almost like similar to something, if you've ever used Presto, where it acts more like a SQL engine on top of things. So it creates its own kind of logic layer on top. If you've ever used Denodo, it allows you to kind of interact and develop views and things like that that are then improved as far as performance goes, but they still live in your original data source. So you're not having to spend time creating a duplicate layer of data, but instead you just have this virtual layer of this data where a lot of the indexes and stuff are tracked in Denodo itself. The one thing I think I've often noticed here is it still takes a lot of time. I think Denodo and some other data virtualization tools do have some learning curve. You do have to spend time actually learning what they are, how it works, and things like that. I like to say it's reduced the risk of data errors, sort of, only because you're not having to deal with transforms, so you're not dealing with as much processing, but you still have the risk of data errors in your source data. So it's not like you're solving all your problems, you're just solving some problems. Again, similar to in ELT, you're kind of reducing the time that it takes to get access to data, but you still have to kind of do something as far as, like, I would say, like core data layering and creating data views. So you're still spending some time writing either some queries or creating data views, but you're spending less time actually duplicating and creating ETLs or ELTs. So I'd say these are kind of some more of the technical solutions that I see a lot of companies trying to implement in one way or another. Again, automate connectors, I think I've seen a ton of time writing custom API connectors for every possible solution. Similarly, ELTs, I think, have their place. I'm still, I think, figuring out how data virtualization plays for all companies, if it fits and where it doesn't fit. Just because I often find there's still somewhat of a learning curve as far as the tools go, but it also, I think, provides some benefits as far as, for the end user. Just improving your data strategy. I think this is kind of a key area as far as the work that I've done and what I've seen, making sure that when you set up a plan, when you set up, when you decide to pull some data from a data source, that it actually has some sort of end goal. I've definitely spent some time working with either clients or internally, finding that sometimes you'll pull data that doesn't really have any goal connected to it, or in terms of maybe it has a goal, but there's no business person on the other side to actually run that goal. Data engineers are not the only limited resource. You also have, limited business partners on the other side that can actually implement possible goals if you actually pull that data in. So even if you have a data engineer pull that data in and a data analyst, create some sort of dashboard, you may not actually have anyone on the other side to act on it. So that dashboard might just kind of die off or not get used because no one's really sure how it should be used. And so I think that's a whole other side to this. It's not just about infrastructure and picking, better infrastructure tools. I think it's also about ensuring that you pick and have data sets that actually align with the rest of the business goals. Again, there's tons of data sets you can pull from. Working with and consulting for companies, even in the 7 and 8 figure range, they'll often have 5, 6, 7 possible data sources to pull from as they're using tools like, again, Asana or Salesforce or Shopify, and they want to get all this value from it, but it's going to take a lot of time, especially if you're using more traditional infrastructure. But even if you switch to using something like an automated connector or a Fivetran or whatever your business can afford or wants to utilize for your strategy, at the end of the day, you still need to be able to act on that data. And so I think that's one key area I would always kind of instruct both clients and anyone trying to improve their whole data process. Don't just try to essentially fix the problem in terms of pulling in new data or hiring new data engineers. Also make sure on the other side that you have business partners that can actually act on that data. Otherwise, they'll pull in the data and nothing will really happen to it. So I always like to say, plan out what you're going to do with that data. How do you think you could use it? Obviously, it doesn't have to be concrete, but just in general, what are some, why are you pulling that data? Write that down. Put together a quick 1-pager of the value and what you think you could do with that data and who will actually run point on that whole task. Don't just let it kind of die off with the data engineer and data analyst. Make sure that there's some sort of business partner attached that will really run that goal and kind of bring it home. Okay, so just some general challenges as far as adopting some of these changes. And actually, I didn't even include this, but migrations is one of them, obviously. It takes a lot of time to switch over from any system. If you've already kind of developed a homegrown ETL system that maybe isn't really working, it's very difficult to switch regardless because it's going to take a lot of time, whether you want to pick Airflow or some sort of drag and drop solution. Migrating takes a lot of time. It takes a lot of money. It's very easy that your company is going to spend upwards of $100,000 to switch some sort of ETL system. Even if it's a smaller company, it's depending on how integrated that is, it's a very expensive switch, and it also again slows down data engineers from doing the work that they're currently doing. Another thing is cultural. Depending on your teams, they might be very accustomed to kind of building their own kind of ad hoc pipelines, or they might be accustomed to using the tooling that they're used to, and so it might not be their favorite thing to switch. And so cultural changes and buy-in, I think, is often another point to it. Depending on the tool you pick, also, there can be a high learning curve. Some of them are very easy to use, some of them aren't. I do think that, I generally don't always like getting locked into a specific tool just because I think maybe I like programming more. So I tend to lean more towards things like Airflow, just because that's something that is very flexible and I can change it the way I want. Whereas specific tooling or something like Matillion or Fivetran or something similar, there's a lot of buttons and understanding that I'd have to go through, whereas I know code and code doesn't change. So there is some sort of learning curve. Similar thing can be said about like data virtualization, where that's a whole other concept. It's a paradigm shift, and you have to change a lot of what maybe your current data engineers know as far as best practices and how to model data into a different kind of system. So you're not going to get around having to spend some time either training or bringing in someone that actually maybe knows these tools a little better. Next, vendor lock-in, especially if you're using maybe more of a custom code solution or even something like Airflow, where these tools are arguably somewhat free. Picking a tool like Fivetran, Matillion, Denodo, you're going to spend a lot of time to integrate these systems, and depending on how expensive they get, you could feel very locked into them. And it can be very difficult to switch, especially if you have set up your entire infrastructure with that kind of low code, no code solution, and no code at all. That might in turn result to you having to spend a ton of time just re-changing your systems, as well as possibly hiring people that can actually build the pipelines in Python or whatever code you're picking, because before you're using kind of low code, no code, so you hired possibly employees and teams that could do that, and now having to switch could be very expensive and very difficult. So I always like to point that vendor lock-in is very easy with these tools, just because again they're kind of built that way, I think. Okay, and just as kind of another quick pause, we're getting pretty close to the end here. I just want to ask, if you're out there as a data engineer, I'd love to hear kind of maybe either your questions that you have as solving the bottleneck, but also I'd love to hear how your companies are trying to solve the bottleneck. I think, this is an ongoing conversation that we're having. Again, I think this is the current, at least a very current problem I hear across industries. I've talked to, I think, people, and I've worked long enough to just have seen this problem repeat itself over and over again. And then also just the fact that you're seeing companies like Fivetran get billion-dollar valuations, I think just further kind of cement the fact that this is a major problem that people are trying to figure out how to solve in one way or another. So I'm just curious if anyone has any either questions or comments as far as how they're seeing this being solved, or how they're seeing, or how they think it could be solved more effectively.
Well, Ben, we got a question.
Sure.
The question is, any way to predict if a particular ETL, ELT tool might stop working as data gets bigger? For example, Fivetran or Pendo connection worked for us when data was relatively small, but it stopped working after data got over 1 million recs a day.
Huh. That's definitely interesting. I think Fivetran is more interesting because you would assume you'd start seeing some sort of failing. I don't know if Fivetran has anything as far as like giving a limit to how much they can handle. I would assume since they're cloud, they would let you pull in as much as you want. Like with general ETLs that are code, you'll often, I think, start seeing problems eventually. Either things start taking longer. I think that's generally the thing that will lead to failures. Like eventually you just start seeing tasks take a long time. I don't know if that was something you were seeing. Just tasks start getting more and longer and longer, and eventually just get really slow. Also, what do you mean by failing? Do you mean like they're timing out, or do you mean again like they're now taking like 24 hours and it's pointless for you to run them, I guess?
Well, when they get their answer to your question in, we have another one that's come in. As someone who's always coded bespoke solutions, I'm curious about the setup adaptability of some of these quote unquote connectors you've mentioned. How customizable are they? I.e., I've gone down the spaghetti path.
Yeah. So I think there's different kind of layers, right? Like, or there's like, I think there's personally, I like to think there's like 3 sort of categories. You have the very custom code, I'm building it myself, spaghetti path. You have the semi kind of middle ground where it's something like Airflow or Luigi that have a lot of the infrastructure there for you, and you're going to have to spend it's code, so you can have some flexibility. You can kind of write what you want. And they don't necessarily have all the automated connectors, but at least you can write your own code, and it will manage a lot of the other heavy lifting things like dependency management, timing. You're not having to kind of put all this together yourself. And then you've got kind of this low code, no code option that has existed for a very long time personally. Like I think a lot of them are selling themselves as new, but we've had SSIS for forever, this drag and drop and other similar tools like MicroStrategy. The only difference is now, things like Fivetran. There are definitely some challenges there. Like Fivetran doesn't have every connection out there. So sometimes you have to set up custom connections, which, then you're having to write code regardless, somehow or another. Obviously, they are a little stiffer. Like they're not going to be as fluid. So if you want something very specific, it's going to be challenging. One thing I was looking at with Rivery.io, so that's kind of a newer tool that I've seen. They do have a request API connector. So I think that's something that's worth at least looking into more, depending on how effective it is. You don't have to write some sort of abstracted request API connector yourself. You can use this tool. Again, as you kind of go down that spectrum, as tools become more low code, no code, it just inevitably becomes less flexible, right? Like that's just how it's developed. That's how the system works. In the middle, again, that's why I think I tend to lean towards like Airflow or something that already has a lot of the heavy lifting done for me, because then, I get the flexibility that I want, but maybe I still have to do some custom coding. I think next I'm kind of trying to work more with something like Airbyte to figure out how to, connect Airbyte to Airflow so I don't have to develop as many connectors. Because Airbyte's kind of more of a command line interface option, and they should have a lot of those connectors already developed. So that's still a little bit of a newer tool, but I think that's like my current work and focus is trying to figure out how to take automated connectors with something like Airflow, so then I can really manage that whole process better.
Going back to the previous question about failures with a lot of data, Fivetran couldn't sync or catch up once it got behind.
Oh, interesting. Yeah. So I think that's generally a problem, especially with, I'm surprised again, like I assume Fivetran could scale somehow, but you have that same problem, I think, with even normal pipelines. Eventually it just becomes so much data, it becomes difficult to manage. And then you have to start thinking about either distributed systems or streaming data, just getting that data live. So, I mean, again, it depends on your specific problem that you ran into, but in general, that might be more of a place where either you've got to create more of a custom connection because it's more of the data problem, right? Like it's just so much data that even these tools I think are built more for really trying to manage very specific cases. And they're great at it, but I think, once you start getting more custom and like very big data, I think these tools have a lot of ground to cover. I'm sure that eventually they'll get better at it, but I think at this point, I think that's a constant problem that you'll have. I mean, again, I have that problem even with other tooling or even more custom code solutions where you've got to figure out a way to either break up that data or process it in such a way across multiple nodes, because again, it just gets so much that processing it on a single node or processing it in batches doesn't work anymore. So I think at a certain point that might be more of what you have to do is you just have to change your paradigm for whatever data you're dealing with.
Okay, and that's all the questions we've had so far.
Great. I think I only have like three more slides left. Just kind of asking the question to myself as well as everyone else. Will we fix the data engineering bottleneck? And I think the general answer is currently probably not. We're probably going to deal with this problem for a little bit longer. Again, like I said, as tooling gets better, we have plenty of options. Again, things like automated connectors, ELTs, improving data strategy, data virtualization. There's a lot of options, but I think we're still trying to figure out how it all fits together. I think that's kind of the key here. It's rather than trying to solve each piece very individually, it's really trying to put together that improved data strategy and more of a centralized but decentralized process. I think the thing that I've seen companies do well, and the companies that I think have kind of succeeded at reducing the amount of time it takes to produce data pipelines, have kind of migrated away from doing more decentralized processing where every team kind of has their own ETL tool, but they've kind of developed one team that manages some sort of ETL infrastructure, and then all the other teams just kind of push to it. So one team is basically managing all the errors and possible problems, or at least the notifications and the data quality kind of checks and more abstracted things like that. And other teams are possibly focus more on just building the pipelines. So I think that's something I've seen be successful, and especially once you connect that with things like automated connectors, I think you start getting a lot of benefits. So I think we are slowly solving this problem, but I think for probably the next 3 to 5 years, we will continue to have this problem, because even if you were to switch to something like, again, a 5-tran or another ELT style tool, you'll still have to spend a lot of time migrating and switching and getting everything synced over. So I think for now, we will continue to have this problem. I think there are a lot of possible solutions. I think, again, one of the biggest things I recommend for most companies is make sure that whatever data you're pulling actually aligns with your overall business strategy and isn't just data that you're pulling because you think it would be interesting to look at. I think that's probably one of the key areas you can focus on, because again, you have limited resources and you kind of need to be responsible for how you use them and how you're going to actually use the data, as well as, you know, people's time, because it's limited and you can't do everything at once. So just some final key takeaways personally. So the demand for data engineers is growing. Hopefully that's obvious, and I don't see it reducing anytime soon. If anything, again, I think we'll see it continuing to grow. Also, one very quick way to improve kind of the way you implement or reduce the time it takes to get to your data is just by changing your infrastructure into something that is a little more effective, where you're not having to manage all the custom stuff yourself. This does depend on your company size. You know, if you've got 2 data pipelines that you run once a month, do you need to set up infrastructure? Probably not. If you've got 100 data pipelines that you're running every day, you probably should have some sort of infrastructure in place that's not custom coded, and you know, your poor data engineers are having to check what failed in the morning through some email notifications that they set up. So that's just something that I'd say, you know, making sure you pick the right infrastructure can have some major impacts on the time you spend engineering and you know, dealing with errors and maintenance, and as well as I think another aspect is, I didn't talk about this, but like maintenance in the future. You know, if those data engineers leave that built that original infrastructure, you know, they're not going to leave behind kind of a mess that some poor data engineer in the future just barely holds together. And then finally, you know, data engineers need to be better aligned with business and understanding what they're pulling and trying to help make those decisions to make sure they're only pulling what needs to get pulled and not pulling, you know, way too much information that maybe has no value for your company. All right, and with that, I'm kind of wrapped up. If anyone has any questions, other than, you know, feel free to ask now. Otherwise, thank you so much for your time. I really do appreciate it.
So on that note, I'd like to thank you too. Thank you, Ben. This was wonderful. This was, I mean, pretty thorough and engaging. So I really do appreciate your time, your effort here. And thank you to all of our attendees who joined us, who spent a little bit of your day with Postgres Conference. And I guess with that, I hope to see you on future webinars.